Phoenix just spent an entire night that never dropped below 97 degrees, only about 3 hours under 100 from 4:30 in the morning until dawn. That ties the warmest night ever recorded in the city, and it came on the same day the thermometer hit 117. But the record itself is not the story. The real story is what the strongest heat dome of the summer does to the country if it holds for weeks, exactly the way the forecast says it will. Stay with me, and you will understand what has scientists genuinely alarmed. On Friday afternoon, at 14 minutes past 3, the official thermometer at Phoenix Sky Harbor International Airport hit 117 degrees. That reading broke the daily record for the date, topping the 116 degrees set back in 2023. And it did not arrive alone. Yuma reached 116 the same afternoon. El Centro, just across the California line, hit 117. Desert readings above 115 degrees were widespread up and down the lower Colorado River Valley. But the afternoon number is not the one that matters most. The number that matters most came after dark. When the sun went down Friday night, Phoenix did not cool off. The low bottomed out at 97 degrees. That ties the warmest overnight low ever recorded in the city, a mark first set in the summer of 2023. And it means the fifth largest city in America spent only about 3 hours below 100 degrees across an entire night, roughly from 4:30 to 7:30 in the morning. Then the sun came up and started the whole thing over again. Hold on to that 97-degree night, because it is the key to everything that follows. A hot afternoon is uncomfortable. A hot night is dangerous. The human body cools itself down overnight, and when the night never gives that relief, the heat load just keeps stacking, day after day, with no reset. That single record day paired with a record-tying night is the sharpest point of a structure that now covers roughly half the country, and today it is still getting stronger. To understand how close this is running to the edge, you have to know the ceiling. Phoenix's all-time record for any day in any month is 122 degrees, set back in June of 1990. That day is a piece of local legend because commercial jets were actually grounded at Sky Harbor, since the performance charts the pilots relied on did not even extend that high. The current forecast, topping out near 120, approaches that all-time mark without quite reaching it. But the raw record is almost beside the point. What tells you how relentless this is comes from the people living inside it. Local reporting describes homes across the valley holding steady in the high 80s indoors, with the air conditioning running continuously and never catching up. And one resident summed up the mood by simply calling the heat the devil himself. That is what a dome at this strength feels like from the inside, and it has not peaked yet. The engine behind all of this is a heat dome, a massive ridge of high pressure parked over the southwest and central states. And here is what makes this one different from an ordinary hot spell. As of yesterday morning, the National Weather Service had 431 active alerts posted across the country. That is up 78 in a single day, from 353 the morning before, one of the largest one-day jumps in weeks. 49 of those are extreme heat warnings, 90 are heat advisories, and 20 are extreme heat watches, and they stretch from the Mojave Desert all the way to central Iowa. Now, an extreme heat warning covers the Phoenix metro into Monday, with afternoon highs forecast between 110 and 118, and the possibility of a reading near 120 as the dome peaks. Death Valley and the Coachella Valley are both forecast to reach as high as 120 degrees. And the alert count is climbing while the dome is still building, before it has even hit its forecast ceiling. And this is not just an Arizona story. The alert map shows how enormous the footprint really is. The heaviest loads yesterday were in Iowa, with 34 separate alert products, followed by California, Nebraska, Kansas, Minnesota, and Montana. The forecast office in Des Moines is calling for heat index values as high as 112 across multiple blocks of counties. And there was a detail in Iowa that captures exactly how loaded this atmosphere is. The same counties that woke up yesterday to dense fog with visibility down to a quarter mile are the ones forecast to hit a 112-degree heat index by afternoon. Fog at dawn and a dangerous heat index by mid-afternoon in the same place on the same day is the signature of an atmosphere absolutely soaked with moisture. And that moisture is what makes the heat so hard on the human body. Out west, the forecast office in Las Vegas has desert valleys running 108 to 114, possibly topping 115 along the Colorado River, with overnight lows that only fall into the 80s and 90s. Down in the Coachella Valley, highs could reach 120, with nights bottoming out in the mid-80s to mid-90s. Everywhere under this dome, the same pattern repeats. The days are brutal, and the nights refuse to recover. That ceiling is what has forecasters watching closely. Model guidance is building the ridge to a height of 600 decameters over Utah by the end of this week. If that means nothing to you, here is the translation. Upper air height is a direct measurement of how warm and how tall the column of atmosphere is, and a 600 decameter value at the 500 millibar level is among the highest ever measured over the interior West. In plain terms, the models are forecasting this dome to reach about as strong as a heat dome over this region can physically get. And it is not leaving this weekend. The Weather Prediction Center's extended discussion is blunt about it, warning that extreme heat will keep making headlines across a large expanse of the country well into the coming week. The forecast holds the ridge dominant all the way into the first day of August. The Climate Prediction Center has already flagged another round of extreme heat for the southern plains and the southwest between today and Tuesday. Even Denver is in on it. Denver's July record of 100 degrees, set back in 1910, is in play today. That is a 116-year-old record that could fall this afternoon. So the honest question is not how hot it gets this weekend. It is what happens if this dome holds for weeks, because duration, not peak temperature, is what turns a heat wave into a mass casualty event. And to understand why forecasters keep using that word, you have to understand why these domes are so hard to break. A heat dome is a self-reinforcing machine. The air sinking underneath the ridge compresses and warms as it descends, which suppresses clouds, which lets even more sunlight pour onto the ground. Now add the drought. When the soil is dry, and right now roughly 65% of the country is at least abnormally dry, that incoming sunlight has no moisture to evaporate. So instead of going into evaporating water, all that energy goes straight into heating the air. The hotter air strengthens the ridge overhead, the stronger ridge suppresses more clouds, and the loop tightens on itself. This is the drought heat feedback, and it is the specific reason a strong dome resists breaking down. This one is sitting on a severe drought floor covering nearly 30% of the country. The fuel for its own persistence is already loaded underneath it. There is one more ingredient loaded underneath all of this, and it raises the floor on everything. The Pacific is currently in an El Niño state. The main ocean index used to track it reached plus 0.98 degrees this spring, a swing of more than 1.5 degrees in just 6 seasons from the cool conditions of late last year. What that means in practice is that this dome is not building on a normal summer. It is building on a globally warmed El Niño-loaded baseline, so every record it threatens starts from a higher launching pad than it would have a generation ago. That is why the overnight number is the one to watch. The daytime highs grab the headlines, but the nights are where the danger actually lives. Think about what your body is actually doing overnight during a heat wave. It is trying to shed the heat load it accumulated all day to bring your core temperature back down to a safe baseline before the next day starts. When the outside air never drops below the high 90s, that recovery simply does not happen, and you begin the next day already behind. Do that for 2 nights, and most healthy people cope. Do it for 2 weeks, and the vulnerable start to fall. Every system that keeps a person alive inside a heat wave, the human body, the air conditioner, the power grid, is a system with a limit, and every one of them is designed to get a break at night. When the nights stop cooling, those breaks disappear and the failures start to stack. To see exactly where that leads, you only have to look at what happened the last time the same atmosphere ran this same experiment. The template is Phoenix, 3 summers ago. In July of 2023, Phoenix ran 31 consecutive days at or above 110 degrees. The old streak record was 18 days, set back in 1974. So this did not just break the record, it nearly doubled it. The average temperature for that entire month, day and night combined, was 102.7 degrees. That is the hottest month ever recorded in any city in the United States. And here is the part that matters for right now. That summer, 645 people died of heat in Maricopa County alone. To put that in perspective, that was more than half of every heat death reported to the CDC across the entire country that year, from one county. 64% of those deaths happened in July, the same stretch of the calendar we are walking into right now. But the most important detail is the timing of those deaths, because it tells you how this kind of disaster actually unfolds. The deaths did not spike on the hottest afternoon. They lagged the temperature curve by weeks. Heat mortality is cumulative. It builds slowly, night after night, as bodies that never fully recover keep falling a little further behind. And it falls hardest on the elderly, the isolated, people who work outdoors, and people with nowhere cool to go. That is what duration does. It is not one lethal afternoon. It is a slow grind that keeps collecting for weeks after the cameras have moved on. And Phoenix is not the only entry in this ledger. The other classic American case study is Chicago in July of 1995, when a heat wave killed roughly 739 people in the span of about a week. Chicago is the textbook example precisely because the killer was the same combination we're watching build right now. Warm nights that never let up, high humidity and social isolation, elderly residents alone in upper-floor apartments with no air conditioning and windows they were afraid to open. Then there is the opposite kind of warning. The Pacific Northwest in the summer of 2021, when a heat dome parked over a region where extreme heat is rare and infrastructure was never built for it. The town of Lytton in British Columbia hit 121.3 degrees, an almost unimaginable reading for that latitude, and then burned to the ground the very next day. Hundreds of people died across the region. The lesson from all three is the same. Chicago, the Northwest, Phoenix, every one of them was a duration event, and every one of them killed most heavily not at the peak, but in the days and weeks the heat refused to break. And as frightening as those numbers are, they are still not the worst case. They are the baseline. The worst case is the one scientists have actually put a number to. Here is the scenario that keeps heat researchers up at night, and it is the reason you keep hearing the word alarmed. It is not the heat by itself. Phoenix, after all, survived 2023 with the power on. The nightmare is the heat, plus a blackout at the same time. A team led by Brian Stone Jr. at Georgia Tech modeled exactly that, and published it in the journal Environmental Science and Technology. They asked a simple question. What happens if Phoenix loses power during a multi-day heat wave? The answer was staggering. Their model projected that a blackout during a major heat wave would kill roughly 12,800 people in Phoenix and send about 790,000 residents to the emergency room for heat-related illness. That is close to half the population of the entire city needing emergency care in a matter of days. Now set that against reality. The Phoenix hospital system has only about 3,000 emergency department beds. There is no version of that math that works. Stone himself called a blackout during a heat wave, and this is a direct quote, probably the greatest climate-related hazard we can imagine. The reason is simple. Phoenix is a city that survives its summers entirely on air conditioning. Cut the power in a modern, sealed home during a heat wave, and the indoor temperature climbs past the point of survival within hours, not days. That local detail from this week, that homes are already holding in the high 80s indoors with the air conditioning running non-stop, is the leading edge of exactly that scenario. The margin between uncomfortable and unsurvivable in Phoenix is the power grid. And the study did not just diagnose the problem. It found that shading half the city's streets with trees would cut those projected deaths by 27%, and that putting reflective, cool roofs on every building would cut them by 66%. The fixes exist. What is missing is time. Which brings us to the part of this that turned from a hypothetical into a live warning just this week. The Stone study was a projection, a what-if. But this summer, the what-if conditions are lining up on the board in real time and not in Arizona, in Texas. Last Tuesday, the grid operator that runs about 90% of the Texas power system logged a demand of roughly 87,400 megawatts. That is a new all-time record. It beat the previous peak of about 85,500 megawatts, which was itself set during a heat wave back in August of 2023. And the operators are warning it goes higher from here. They are projecting a summer peak above 90 gigawatts, enough electricity to power roughly 18 million homes. Part of that surge is the heat, driving air conditioners across the state to run flat out. But part of it is new. Power-hungry data centers and crypto mining operations are piling load onto the grid on top of the weather, at the exact moment the dome is pushing demand to its limit. This is what the researchers meant. A grid does not have to be hit by anything exotic to fail during a heat wave. It just has to be pushed to its ceiling and held there, day after day, until one hot transformer or one failed line at the wrong moment cascades. And extreme heat attacks the grid from both ends at once. On the demand side, tens of millions of air conditioners run flat out and never cycle off, because the nights never cool. On the supply side, the heat itself degrades the equipment. Transformers and transmission lines carry less power safely when the air around them is scorching, and the big transformers that anchor the system run hotter and age faster the longer the heat holds. So the exact moment demand hits an all-time peak is the same moment the hardware delivering that power is at its most stressed. That is the trap. It is not one dramatic failure. It is a slow tightening of the margin between what the grid can deliver and what the state is demanding, until a single component gives out at the worst possible hour and the failure spreads. A record demand in the middle of a strengthening dome is precisely the precondition the Phoenix study was built to warn about. And the heat is not only stressing the systems we plug into, it is discharging its own energy in a far more violent way along its edges. Here is something a lot of people miss about a heat dome. All that heat piled up in the interior is stored energy, and along the northern rim of the dome, that energy gets discharged violently. The reason it concentrates on the northern edge is simple. That is where the scorching dome air collides with the cooler air and the faster winds riding along the jet stream to the north. The dome acts like a wall, and storms ride around the top of it, fed by all the heat and instability packed underneath. Forecasters sometimes call it the ring of fire, and it turns the boundary of a heat wave into a corridor of severe weather. Friday alone produced 51 preliminary severe weather reports across the northern plains. 1 tornado, 36 damaging wind reports, and 14 large hail reports, up from 20 the day before. The standout was Forbes, North Dakota, where 3-inch hail was reported, falling for roughly 8 minutes straight, smashing windows. That duration is genuinely bizarre. A giant hail core normally crosses a given point in well under a minute. 8 minutes of baseball-sized stones means a slow-moving, continuously regenerating storm, exactly the kind of behavior a deeply overheated, deeply unstable atmosphere feeds. Wind gusts told the same story, 89 miles per hour south of Wing, North Dakota, 78 at the Albuquerque airport, and a tornado on the ground near Middle River, Minnesota. And it is not finished. The Storm Prediction Center has central Montana and parts of South Dakota in the crosshairs, and the mechanism is directly tied to the heat. South Dakota bakes to near or above 105 degrees first, which builds a deep, bone-dry, well-mixed layer of air near the ground. Then, storms rolling off the higher terrain tap into all that stored heat and convert it into localized gusts of 75 miles per hour or more. Today, that threat shifts east into the upper Midwest, with the potential for those storms to organize into a single fast-moving complex overnight. This is not a separate story from the heat. It is the same energy coming out the side of the same machine, and underneath all of it, the dome is quietly grinding on the ground itself. While the headlines chase the temperature records, the dome is doing slower, quieter damage that will show up in the coming weeks and months. Start with the food supply. This heat is intensifying at the worst possible moment for American agriculture, right as corn and soybeans across the plains and the Corn Belt hit their critical reproductive stage. That midsummer window is the one that decides the final yield for the entire year. National ratings still show about 67% of corn and 64% of soybeans in good to excellent shape, but hot, dry conditions are steadily draining soil moisture across the central and southern plains. Extreme to exceptional drought now covers about half of Nebraska. Pastures are deteriorating, and ranchers are already facing rising feed costs, the kind of pressure that eventually ripples out to grocery prices for everyone. Then there's the fire line. NASA's satellites detected 3,561 wildfire hotspots in a single 24-hour period. Several large fires are already burning at single-digit to teens containment, with the biggest running well over 140,000 acres. Red flag warnings stretch across Idaho, Montana, and Oregon, with afternoon humidity dropping as low as 13%. And this is the same feedback loop that helps the dome survive, running in the other direction. The drought dries out the fuels, the heat bakes them further, and the parched ground can no longer cool itself through evaporation, which feeds the heat right back into the dome overhead. Every additional day this dome holds cures the vegetation a little drier and pushes the fire danger a little higher. In a fuel bed like that, all it takes is a single outbreak of dry lightning, thunderstorms that deliver plenty of lightning but almost no rain, and a fire season detonates. That is exactly the kind of storm the edge of a dome tends to produce. And there is one more twist, a genuine no-win built into the pattern. The ring of moisture around the dome's edge is the region's only natural exit ramp from the heat, but that exit has a trapdoor. If that moisture surges, it does cut the afternoon temperatures, but it dumps heavy rain onto fresh burn scars and slot canyons, ground that can no longer soak up water, turning a heat emergency into a flash flood emergency in a matter of hours. So the dome offers two paths, and both of them lead somewhere dangerous. It either holds and the heat grinds on, or it breaks the wrong way and trades the heat for floods. This is the box the Southwest is in right now. The very moisture that could offer relief is also the thing most likely to turn deadly the instant it arrives over ground that has been baked hard and stripped of vegetation by fire. There is no clean exit, only a choice between two kinds of emergency, and that is a large part of why the coming weeks have people who study this for a living so uneasy. Anytime a dome like this parks over the country, two claims start circulating online, and they are worth addressing head-on because the honest answer is more interesting than the myth. The first is that the dome is engineered, that someone is manufacturing this heat with weather control technology. The problem is the energy budget. Reorganizing the thermal structure of the atmosphere across millions of square miles takes an amount of energy that dwarfs anything any facility on Earth can produce, by many orders of magnitude. And this dome was forecast days in advance by physics-based computer models running on public data. An engineered artificial anomaly would break those forecasts. It would not confirm them right on schedule. The second claim is that the records themselves are fake, inflated by hot airport thermometers. And this one actually has a real kernel worth respecting. Airport sensors genuinely can run a few degrees warmer than nearby neighborhoods because they sit on large, flat, dark surfaces. But a temperature record is not a comparison between the airport and someone's backyard. It is a comparison of that one station against its own history, the same instrument at the same site across decades. And the single fact that dismantles the whole theory is that 97-degree overnight low, a reading that, high at 4 in the morning, cannot possibly be a sun-baked tarmac artifact, for one simple reason. At 4 in the morning, there is no sun. The record that this theory cannot touch is the very one that is most dangerous. So where does this go from here? There are a handful of specific checkable signposts that will tell you which way this breaks. The first is that 600 decameter ceiling over Utah. If the dome actually reaches that height late this week, it confirms this is one of the strongest heat domes ever measured over the interior West. The second is Phoenix's overnight lows. Watch the nights, not the afternoons. A run of lows staying up near 90 degrees is the exact signature of 2023, and it is the real measure of how much danger is accumulating. Third, watch the national alert count. It jumped from 353 to 431 in a single day. Whether it keeps climbing or finally crests will track the dome's expansion in real time. Fourth, watch grid demand in Arizona and Texas as the week peaks. Texas already set an all-time record last week. Every new record edges the system closer to the precondition that Phoenix study warned about. And finally, watch the calendar. The forecast holds this pattern into the first days of August, the exact window that produced Phoenix's 31-day streak 3 summers ago. The straight read is this. The strongest heat dome of the summer is still strengthening. It has already delivered a record day and a record-tying night in a major American city. And the national forecast keeps it locked in place for weeks. Duration is the variable that turns heat from a nuisance into a disaster, and every indicator right now points to duration. The good news is that domes do break. A trough could dig in over the east and shove this one west. The monsoon could surge. August could open with the pattern finally relaxing. That is a real possibility, and it is worth holding on to. But the forecast, as it stands today, is for persistence. And the question this heat is forcing is not how hot it gets this weekend. It is which gives out first in the weeks ahead, the pattern, the records, or the systems we depend on, and whether the answer arrives before or after the first big failure. We will be tracking every one of those signposts as this develops.